Everyone, can everyone hear me?
Yes.
Perfect. I'm joined by my esteemed colleague, Dean Jones, who's the branch general manager as well. Let me just bring up my screen. Screen three. Can you guys see my screen?
Yes.
Perfect. Good evening, everyone. My name is Haris Murtaza from Alsco. I'll do a formal introduction on the next slide. Just letting everyone know, if I look tired, it's because I'm dialing in from Sydney. It's almost 8 o'clock here. Haven't had dinner, and I've got a very young baby who doesn't sleep. So everything on top of each other right now. Um, yeah, so Elsko Uniforms, I'll pass it over to Dean to talk through a little bit about Elsko and introduce himself, and then we'll get into the challenge statement.
Hi everyone, my name's Dean Jones. I'm the branch general manager from Alsco Uniforms in Singapore. We're a worldwide uniform rental company. The basic premise of our business is that we provide garments to our customer base, and as part of that rental, on a rental basis, and as part of that rental, we launder them. Um, we're in 15 countries worldwide with about 200 branches and around 200,000 customers around the world. So basically, what we're trying to do as an organization is to reduce our carbon footprint and other measurements that are driving towards sustainability. And primarily, what that is, or our primary emissions are based around either transport, which we won't get into today, or the processing of those launderable items. And so Harris looks after sustainability in the region, and I've asked him to assist in designing some potential projects that we can offer. Thank you, Harris.
Perfect, thank you, Dean. Yeah, so Energy Utilities Manager for Alsco. I've previously been based in New Zealand and now based in Australia, so do work for Alsco Uniforms across the region. Just a little bit about our challenge statement. So we've got two to go through. The first one is to recover and reuse waste heat from our industrial gas dryers. So as Dean said, we're a commercial laundry. We wash, dry, and iron our textiles. So we've got big industrial grade dryers, 200 kg dryers that have latent heat of about 150 to 180 degrees go out from the exhaust at any given time. And then we've got cool inlet air coming in from the atmosphere, which is heated either using steam or it's heated using a direct gas burner. So primarily we've got gas dryers, but in some instances we've also got steam dryers in our facilities. So we've got hot air being vented out, and there's no heat recovery or energy recovery on that, and then we're pulling in air and then heating that up further. So there's a potential to do some heat recovery. We've tried to do this in the past. Unfortunately, lint has been a massive issue. So a lot of the lint going out, it's been caught up in the heat recovery units, and it's posed a fire risk. So we need to do a study where we can get rid of the lint problem, and therefore we've listed some technical requirements. So we want to do heat recovery on 150 to 180 degrees and heat up the inlet air coming in. It should be self-cleaning and have lint removal features. It should ensure that there's no fire hazard. It should recover heat for reuse in air preheating. Must avoid any back pressure, so you can't take out too much heat. If you go below the dew point, then you'll have back pressure, which will affect the efficiency of the dryer. So even though we're doing heat recovery, we can then negatively affect the running of the dryers, meaning that they'll start using more gas. So that will lead to adverse outcomes. We've got to make sure that any heat recovery material used should be non-flammable, um, corrosion resistant, and capable of continuous high temperature operation and recovery. And it should comply with relevant industry fire safety standards. If we can do a proof of concept, a POC, we've got we've got more than 80 dryers in the region. So there's a massive opportunity here to do heat recovery on all of them, even if we can do one proof of concept. So um, the emissions reductions across all of Alsco is about 25% reduction in our greenhouse gas emissions. So this photo I took online, but we did about 10 years ago. Alsco in America did try to heat recovery using a similar system like this. However, we had lint build up from the residue of the textiles, and it started smoldering, and we nearly had a fire. So we have tried in the past. It's just about finding a solution that mitigates any fire hazards or anything as such. So that's our first problem statement. Did anyone have any questions or any comments or anything they would like to clarify or anything that you would like to add, Dean?
I know that's good. Thanks, Harris. I think you've explained it well.
Cool. I think those on the floor, if you have questions, please start typing to the chat box. And Harris, let's I think move on to the next one.
Perfect.